Assalamu alaikum. Welcome to the fifth lecture in the probability series, right? Now, without wasting any time, let's just dive deep into the lecture. Just to save time on the clock, I've already written the entire question, okay? And this time, I tried my best to keep my writing as clean as I can. I mean, I've never written anything more cleaner than this. And yes, I'm liking the name Amanda and Sarah. Yep, never mind. These are two signature names for these lectures. Never mind. So today we are going to be learning about simple tables. Now, if you were to look for this in the how should I call it? In the syllabus or in the curriculum, you might not see anything called simple tables. Why? Because this is what I'm calling it. It's not a professional or universal word for it. It's just that it is a technique, and this technique I refer to it as simple tables. Why? Because we've got this probability distribution tables, which is what we are probably going to be talking about in the next lecture, right? But yeah, simple tables, this is what I mean. Now look, these are the kinds of probability questions you are going to have to use simple tables for, right? Now look, and normally this is where you use them, where two dices are being rolled at the same time, or two coins are being flipped at the same time, right? Two dices or two coins, right? And the structure for these kinds of questions is going to be someone named a pupil, a student. I'm just going to call her Amanda, right? Amanda rolls two dices at the same time. One is a six-sided fair dice, and the other is a four-sided fair dice, right? Now, what do you mean by a fair dice? That the probability for each number occurring is same, right? Like if the probability for a single dice, the probability for 6 to appear is going to be 1 over 6. I mean, and that is, the probability for 1 or 2 or 3 or 4 or 5 or 6, right? This is what you mean by a fair dice, right? This is why it's fair. Why? Because the probability for each number occurring for a single dice is, same. It's equal. Now look. So in these types of questions, the structure of these questions is going to be two things are going to be happening at the same time. Either two dices are going to be rolled, or not dices. Two die are going to be rolled. This is not DIE. Now look, either two dice are going to be rolled or two coins are going to be flipped at the same time, and then they're going to tell you what the result is, right? So Amanda rolls two die at the same time. One is a six-sided fair dice, the other is a four-sided fair dice. The result is the greater number of the two numbers the die land on. Okay, now look, what I'm trying to say here is that, and then obviously they also give you the numbers on both of the dices, right? And then they ask you to find the probability for a specific result. Wait, the Azan is being called out. I have to stop the recording. Okay, we're back. Now look, Bismillah. So you see, where was I though? Yes. I was saying that in the structure for these kinds of question is that something is going to be happening. Two things are going to be happening at the same time. One thing, and the second thing, they're going to tell you the result, right? And how you're going to create a simple table from there. We're just going to look at it. Now, look, for this question, the result is the greater number of the two numbers that the die roll or land on, right? Or they roll on, right? So let me just make a dice, right? This is a dice. It rolls, right? And you get a six on the. I know this is not how a six is written on a dice, right? But this is just how I'm writing it. Four. Okay. I don't know how do you draw a four-sided die. I did write that in the question, so I'm just going to, you know, I don't know how I'm going to draw it, but let's say this is a four-sided die, and it lands on the top face lands on three. Okay. So in this case, the result is going to be 6. In this case, the result is going to be 6, right? Now, this is not always going to be the same. The result is not always going to be the greater number of the two. Why? Because sometimes they might also ask you, or they might also say, the result is going to be the sum of both of the numbers. Or if both of the numbers are same, then the answer is 0. Or, the result of the number is the greater number minus the smaller number. Or if both of them are the same, you just write 0, right? Or if both of them are, not same, then the answer is 1 or something like that. So these are the things that you have to figure out. Sorry, you don't have to figure them out. They're going to tell you that in the question, right? So this is what I'm trying to say. It's nothing extremely conceptual. It's just common sense. You just have to read the question carefully. I know I do talk a lot, but and I think I've spoken enough. Let's just see how we're going to solve this question, right? Now, this is how you create a table. I make this one thing, first dice and the second dice, right? I'm going to write horizontally all of the outcomes for the first dice, right? That would be 1, 2, 3, 4, 5, 6, right? You can also do it the other way around. Like you can do, like I could have just placed all these in here. Like I could have just done all these in here as well, right? It wouldn't have mattered. And now I'm going to write all of the possibilities for the second one. 1, 2, 3, 4. Okay? Now take a look at how many boxes does it make in here. If I do it like this, how many boxes do I have? Now, the number of total boxes in here, like, look, 1, 2, 3, these are the total boxes, right? The number of total boxes are the total outcomes, right? And how do I find it? What if this was 8 and this was also 8? Obviously, you're not going to be manually counting them 1, 2, 3, 4. I mean, like, you're not a kid, right? This is not how you do it. You can do it if you want, but in order to save time, this is how you do it. In order for you to find the total outcomes, which will be our denominator. We just learned in the very first lesson that the formula for simple probability is what? Favorable outcomes divided by total outcomes. So our denominator is going to be the number for this multiplied by the number for this, right? Which means 6 times 4. And that is 24. So the total number of outcomes is 24. I mean, that could have been like A, B, C, D. It doesn't have to be numbers, right? But the total number of elements in here multiplied by the total number of elements vertically over here. This is what I mean, okay? So our total outcomes is 24. Now, in these boxes, we're going to write the results. For in this box, I'm going to repeat myself. In these boxes, you write your results, right? So in this case, the greater of the two numbers, when both of them are the same. Yep, you know what? In these kinds of questions, they might say, if they are same, take 0 as result. In these kinds of conditions, they do say that, right? So let's do this. If both of the numbers are 0, we just write if both of the numbers are same, we just write a 0. So a 0 over here, and over here, right? And now look, with what, sorry, I didn't touch nothing. Hey, so now look, this and this, which is the greater one? 2, right? So we just write 2 over here. Now look, in here and here, which of these two is the greater one? 3. So we just write 3. It depends upon the condition for the result. Had they asked us to write the sum of the two numbers, I would have written a 3 over here and a 4 over here, right? And now, which of the two numbers is greater in here? 4, right? Now you notice the pattern. It's just going 2, 3, 4. Then obviously this is going to be 5 and this is going to be 6. So you can kind of follow the pattern, and again, it's common sense. Obviously, this is 1. The only, we're just changing the columns. So obviously, we know that the greater number is going to be the one on the top. Over here, this is going to be 2. Why? Because in here and here, which of these two is the greater number? 2, right? And then again, both of these were same, so we wrote 0, and now 3 is greater, over here 4 is greater, 5 is greater, and 6 is greater. In here, 3 is greater, 2 is greater, 3 and 3, you've got the same number, so we just wrote 0, right? And now over here, again, 4 is going to be the greater one, 5 and 6, right? And again, now 4, 3, 2, 0, and then 5, 6, right? This is your simple table. This is a technique which I was calling the simple table. because I didn't know what else to call it. This is a simple table, right? And this is going to be used for these kinds of questions where two things are happening at the same time. I don't know how many times have I said it already. My mother does say I do repeat things and she does get irritated. So I'm pretty sure you guys are also getting irritated. But honestly, can't do much about it, okay? Now look. Now the question was find the probability for obtaining a 4. Now look, the probability for obtaining a 4 would be this notation just means probability of obtaining a 4, right? It's going to be equal to, remember the formula, total outcomes. Total outcomes in this case are 24. And now just count how many 4s we have in these boxes. Do not count these two. These two aren't our outcomes though. So we have got a 4 over here. We have got a 4 over here. 1, 2, 3, 4. So 4 appears 4 times, right? This is your probability for obtaining a 4. That's how you make and use a simple table. This is how you solve such questions, right? And again, like I said, it doesn't always have to be a dice. It could have been Amanda flips 2 coins at the same time, you know, or the coin. If the coin is fair, you know that the probability for obtaining a head would be 0.5, and the probability for obtaining a tail would also be 0.5, right? Why? Because it's a fair coin. Then so both the probability for all of the outcomes should be the same, right? So it's 0.5, 0.5 equals 1. Sometimes the coin that is being flipped is not fair. In that case, they're going to individually tell you the probabilities for obtaining a tail or a head, or a heads, I mean, right? If you want, you can write it in the more simplified version, like 1 and 6, right? Just my math, yep, 6. So you can write 1 over 6 if you want. And that was just, kind of a template. This thing that I've given you over here is just a template for such questions, and the variations are just something that I've told you about. Obviously, when you attempt more past papers, it's just going to get more clear, right? But for now, this is just what it is. A simple technique that my teacher, Salil Iskandar, taught us, and I'm always going to be grateful to him for that, right? I, yeah, that's it. So, inshallah ta'ala, in the next lesson, was it 5 though? Let me check. It was 5. So in the next one, we are going to do actual tables. From obviously they're not called actual tables. Now we have probability distribution. I would rather not write it. Let's just do it in the next lesson. Okay. That's all from my side. Assalamu alaikum wa rahmatullahi wa barakatuh. Take care and a sign from me. That's it. Okay. I'll see you in the next session. In the next lesson. Inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.